It started out as a research project into containerized environments. For many people, these kind of like low-level security mechanisms have been hidden or underutilized. It's a different kind of beast than your average Node.js application. No offense to Node.js developers.
So you basically have like the auditing phase, then you have like the testing phase. You see that if you keep it running for a little bit longer, does something happen which we didn't record? At some point you put it into production and you hope that you just caught all the edge cases.
If they have been used at all, they have been used probably most as deny rules, setting a few boundaries for where your containerized workload can't go.
You really want to secure the services further down the stack, because if somebody can inject some malicious call, your service behaves weird and probably returns something you would not expect. And as you said, breach some security passwords or whatever. Hello everyone, welcome back to this week's episode of simplyblock's Cloud Commute podcast with me and yet another guest. Hannes, welcome. Very glad to have you. And maybe just introduce yourself real quick. Who are you? Where you from? And what do you do?
Well, thank you. Hi, Chris. Nice to be here. My name is Hannes Ullman. Born and raised in Sweden. Right now, currently living in Stockholm. I'm a techie from way back. Used to be the guy all the friends, family called when they had computer issues when we were in the little school. And I probably fixed as many computers that I have broken them as well. But it was I learned early days. I'm one of the co-founders of Bifrost at this stage, and I have a background working in tech for the last 15 years in different areas.
Cool. So you're joining us from Bifrost Security, right? So tell us a little bit about Bifrost, maybe.
Bifrost is a runtime security company, and we focus on helping organizations and companies in securing their applications at the runtime part. So we want to help them analyze and understand the behavior of their software to understand the better behavior and differentiate that from the bad behavior that can cause exploits and vulnerabilities to be exploited into their code bases and gain access into things that that others shouldn't get access to. And we want to help companies limit the attack surface and contain their applications at runtime.
Right. And as far as I know, we've talked a little bit beforehand. As far as I remember, it all started as a university project at Lumpen University. I don't remember the name. Sorry.
No, it's pretty close. It's Lund University in southern Sweden, which is actually my alma mater. So it's pretty fun to be working with something that comes from the same university as myself studied. It started out as a research project into containerized environments and security around containers and new ways of running software, and that run from I think 2018 to 2022, and part of the findings that they thought had potential to be used in a more commercial setting. And these days, universities across Sweden, or I think across Europe in general, have a separate arm that looks to what type of research is being made at our university and what could be actually derived from that and what should be turned into successful products or could be turned into successful products. I think this is a longer lifespan in the life science area, where you have a lot of universities doing science within medicine and things like that then at some point ends up with one of the big pharma companies as well.
Right.
But over the years, there has been a lot of more shift towards the tech side of it. So there has been both software but also hardware companies getting founded on successful research coming out of the universities.
Which I think is much more interesting for the students as well, because you're working towards which is eventually actually being used. I mean, sure, for Madison, hopefully it is being used, but for other things, there's a lot of like this um, theoretical research that is probably never going to get anywhere. But because of, I guess a lot of the people in the audience probably are not aware what the process would be. How does that look like? I mean, is the process, the project or the research actually started with the idea of potentially going into a full-blown product in the end, or how do I have to think about that?
Well, in this case, I would say that the research was done at a EU-funded program that was running across multiple universities and industries in the Europe zone, but had contributors from all over the place. But we had this professor in Lund that was focusing more on the cybersecurity part and the runtime part, and they work within the group, and when they think that they have something that they would like that should probably get funded to become something, they can apply to a certain project or a certain program within the university. That's LO Innovation, it's called, or an innovation program. And they get help assessing whether their idea or their research has potential to become something. And from that, if they are not fully committed themselves into to help you to venture out from the university and get started and start a company and do all the things that that entails, they have a program to get connected with other entrepreneurs that can help you as operators of the startup and help together bring the commercial project to life.
Right.
So that was actually, how I got into this project.
Right. Okay. Got it. Interesting. I've never spoken to anyone who had that like kind of background coming from a university and the project being spun off into a company. That's, I mean, you always hear about those things, but as I said, I've never had the chance to talk to anyone. That's really interesting.
Yeah.
So let's get back to Bifrost then.
Yeah.
Bifrost, as he said, it's a security solution. I'm not sure if it's 100% specific to Kubernetes, but at least it is Kubernetes related. And as far as I know, it uses AppArmor to automatically spin up profiles for AppArmor, right? Is that correct?
Yeah, that's correct. And AppArmor is one of a few different Linux security modules that has been around for quite some time. And the idea behind it is that you can set a few or as many as you want rules around what a given application is allowed to do. And when containers came along, these LSMs were then converted into to also be able to contain your containerized workloads. And of course, you don't have to run this in Kubernetes. We have started with Kubernetes because we believe that it's a very strong foundation and a way of running containerized workloads that has gained traction over the 10 years that it has been. But it's not solely contained by Kubernetes. But and there's a few others as well. We have SE Linux, it's a competing one. There's a lot of work being done now in eBPF, which is also something that you can help and do these kinds of things with as well. So we're investigating those as well as we build this out. But AppArmor is the one we have started with.
Right. I think AppArmor is the one that was initially started by Google for Android, or was that SE Linux? I may just messing that up.
That's an origin story I haven't heard. I think AppArmor came out of Novell and was later acquired by Canonical, and the majority parts of Ubuntu has been using AppArmor for a long time, over I think almost up to 10 to 15 years now, to contain applications for
okay,
Ubuntu.
fair enough. Maybe I'm completely messing that up. But I think it's the one that the Android environment also, or the Android VM.
Yeah, Google for sure is using it because they have also based their cloud optimized OS that runs on their default Kubernetes engine that supports AppArmor out of the box.
Right.
So it comes
Okay.
shipped with it on by default.
Okay. Maybe the audience will lynch me for that, and he got it completely wrong. I mean, perfect.
Yeah,
Perfect.
yeah. I'll help you shield you from a little bit of that, I hope.
Right. Just generate an AppArmor profile for me.
Yeah, exactly.
But to be honest, I think it probably comes from the fact that Android is maybe the biggest AppArmor user, and that's probably why I thought it came out of Google.
Yeah.
Fair enough.
Yeah.
So how do I have to think about that? How does it know how to generate those profiles? How does it know what the application needs or doesn't need?
No, that's a good question. I think that for many people, these kind of like low-level security mechanisms have been hidden or underutilized, and there's been a couple of reasons for that. One, they are close to the kernel, so it's a different kind of beast than your average Node.js application. No offense to Node.js developers or anything like that, but it is, and it's also tricky to use in the manual sense. They come with a way to run them both as allow or deny, whatever it is, and if they have been used at all, they have been used probably most as deny rules, setting a few boundaries for where your containerized workload can't go. And they have, up until now, mostly been manual labor. So line by line, you manually describe what your application is allowed to do or not allowed to do, and you have wildcards and everything like that. But it's tricky and a manual process. And with everything else in the dev tool chain these days being automated for speed and velocity of development, the ones focusing on these low-level mechanisms, they have hard to keep up. So they go unutilized, but that's one of the main thing about Bifrost is we try to change that, and we try to help you automate this process as well as most as possible, so that we can build the profiles automatically for you for every new build that gets deployed to your Kubernetes cluster, so that we can continuously audit during the development phase of your application or the development sprints or wherever, so that we always get the latest developments of what your application is doing. And then we can automatically create the security profiles that evolves with the builds that you produce, so that you can kind of contain the application as it grows of behavior.
Right. A few weeks ago, we had Anders Egnert on the show, and he's working for blanking out with the company name
Stira,
right now.
I listened to that podcast for a while back, and we know each other a little bit, and we meet each other on the Stockholm tech scene as well a few times.
Okay, that makes sense. That makes sense. So he was talking about OTA, like the open OPA, the open policy
OPA,
agent. And I think the idea is kind of similar. Just from the understanding, AppArmor is obviously deeper in the stack because it shields the application from using certain operating system or other applications, whereas OPA was more on the on the service level, basically between different services. But it sounds like those two things would be like a perfect match to be combined and used in tandem, right?
Yeah, no, I think that they combine each other or complement each other a lot, but they are working on different levels. And but what we are trying to do with the AppArmor and Bifrost is that we want to move. Zero trust is a very used term today, but I mean kind of a zero trust on a syscall level, so that you only want your software to do the syscalls and all the IOs that you want it to do, and nothing else should be allowed based on that. So that's the idea with us, that we help you contain the application by looking at its behavior and then crafting profiles that allow for that certain behavior, and then can block behavior that lies outside of that boundary.
Right. So in this case, it's probably closer to something like a web application firewall, where you monitor this behavior of the application or of the traffic for a while, and then you say, okay, these seem to be like the things, or that is the traffic pattern we expect from the application, and everything else we just gonna block. Basically, like what is it, WAF from Amazon?
That's very close. That's very close. Yeah. And I mean, there is a lot of other monitoring tools that use like Falco and Tracy and things like that, that looks to see and tries to monitor for bad behavior. And we think that we can take that one step further by doing that by basically setting up the good behavior rules based on the audit part, and then relying on protecting that in runtime in production with the security profiles that we can produce.
So you mentioned eBPF earlier, and I guess a lot of the automatic auditing is done via eBPF integrations, or eBPF, whatever you call them when they run this in the kernel.
Yeah, so right now we're mostly using AppArmor for the audit parts as well, because AppArmor has an audit mode that helps you understand and get the logs out of any given system. But we could use AppArmor, we could use eBPF for that as well. But we get audit data from a given workload based on the AppArmor audit mode, and then you have two different modes that you run the actual security profiles when you get them from our service. That you can either run them in a complaint mode, which is a non-destructive mode, where it's basically just complaining when you step outside of the boundary that the profile is drawing up for your workload. Right. But then you can also get to a more strict stage, where it's a enforce mode, where you actually enforce the profile.
Right. So you basically have like the auditing phase, then you have like the testing phase. You see that if you keep it running for a little bit longer, does something happen which we didn't record? And then at some point you put it into production, and you hope that you just caught all the edge cases.
Exactly. No, I think from the ones that we have started working with on so far, they are running a few profiles in complaint mode in production as well, just to make sure that they don't trash anything and catch all those edge cases. And we help them analyze the few complaints that we have seen so far, and then once you get to a state where you're kind of boxed in, you rather want to be on the enforce mode, where you proactively would block a bad behavior if that occurs, or an anomaly, that anything that we haven't seen before.
Right. Okay. So from a user's perspective, what would be like the biggest benefit? I mean, I could claim, but why do I need that? Right. I guess one obvious thing would be like a CVE, where somebody manages to get root permission on the container. But apart from that, if I don't have any malicious traffic, why would I care?
Well, that's a good thing. I mean, I think that the whole shift left mentality that has tried to focus on making sure that we get that to the vulnerabilities at the root cause. We still see a lot of applications that goes out to production with a number of vulnerabilities in them. Right. That's just fact. You need to ship features as well, and sometimes there aren't a fix that you can bump, and there's more breaking changes in the fix or things like that makes it so that we have vulnerabilities. And research behind and why this became a venture out of the university was that when you look to a given software stack based on open source components that has vulnerabilities in them that can be used to break into the container, and then in some cases also break in through the node and things like that. If you look to the behavior of what that's actually doing when it's supposed to be doing what it's built to do, you only allow that behavior, and then a majority of those vulnerabilities become mute because they can't do the step 2 or the step 3 and the exploit chain that they have. And being able to contain your application while you still have a lot of velocity in building new features and building and updating your product, still having something that can automatically contain it and understand it as it evolves is one thing that we think is an added benefit. And also, as a platform team, you might be working with multiple dev teams across your companies that is doing a lot of different types of development, that is building different types of services in the containers. And this is a way to raise the level of security between those teams without actually having to work with every developer to have them understand how you actually can use a service like Bifrost or security profiles in general.
I think you mentioned something very important. I just want to make sure it doesn't get lost, because you talked about the attack chains. So these days, an attack or trying to take over a system is normally not a single thing, but it is a chain or a connection of either multiple CVEs, multiple vulnerabilities, whatever you want to call them, or even jumping through multiple systems or multiple microservices, trying to figure out how stuff happens.
Yeah, no, that's true. And I mean, there could be misconfigurations running at some point where if you had not given a security profile that would just tailor to the specific workload's behavior, that you would be able to use that misconfiguration to get secrets out or something that can help you move laterally quicker across a network and across a cluster.
Right. That makes a lot of sense, because now it also means you really want to secure the services further down the stack, because if somebody can inject, you said multiple development teams, if somebody can inject some malicious call that you wouldn't expect, and now your service behaves completely weird. We all know happy wall testing. Right. So now your service behaves weird and probably returns something you would not expect, and as you said, maybe breach some security passwords or whatever. Yeah, that makes sense. Unfortunately, we're already out of time. I would have so many more questions, but one final question, the one basically I ask everything: what is on the horizon? What do you think is like the next important thing, the next big thing? What is like the interesting thing you see in terms of specifically, I guess, security?
You're hard pressed not to have me say AI, but
I know.
which I think it's hard to avoid. But I think if we get it closer to application development, I think AI is a tool like many others, and that will bring productivity. And with productivity comes higher velocity, and with higher velocity comes many more changes. And I think that in of itself, that will give attack vectors. There will be more attack vectors in the future just by having the sheer speed and the velocity of software development being increased by AI. That will bring for more interesting areas, both from of course, how that can be utilized against us in terms of all the ways you can attack software and humans in terms to get access, because still, of course, ransomware also have a large portion of them happening because people are socially engineered to give up secrets that they shouldn't. But I think it will work in tandem. So I think we will see an increased velocity in everything happening, from good things to bad things. And that I think is it's going to be an interesting decade, to say the least, for the digital area.
I think that is a perfect way of ending the episode. There's good and bad things on the horizon. All right. Thank you for being here. It was a pleasure having you. I wish you all the best with Bifrost. I think it's a really interesting product.
Thank you for having me.
No, my pleasure. And for the audience, next week, same time, same place. I hope you listen in again, and thank you very much as well.